So today I actually just wanted to touch a little bit on adaptive bit rate delivery and some of the optimizations that we're seeing, and sort of touch on some of the case studies and some of the best practices that our customers are actually implementing. And so really at a high level, I'm not going to go into this too deeply, there's really this proliferation of devices that are out there. And so you have connected TVs, IP set-tops, everything right down to game consoles, tablets, and smartphones that people are consuming content on. And particularly if you look in my home, that line gets pretty much blurred between what is the first and second screen. If I look at my kids, and I look at a certain extent to my wife, they're watching television on the tablet. The TV is really something that they use for the Xbox, which is actually great for me because I get, there's no fights over the remote control anymore. I kind of get to manage that myself. But in terms of what we're seeing in North America, a lot of the MSOs, a lot of the telcos are actually rolling this out, or they were rolling it out more as a defensive strategy. We're seeing that changing slightly, and you're looking at people like Time Warner, Comcast, Verizon, that are actually now trying to monetize this content. And there's really two ways they're doing it. They're doing it through ad insertion, and they're doing it through subscription services for additional content that's actually being delivered over these channels. And if you look at some of our other customers, we actually have a customer in the Caribbean, Latin America. They provide services into 14 countries, and they have now launched an entire service on adaptive bitrate. So it's smooth streaming to the set-top box, and then HLS and HDS content to all the other devices. And they're actually charging for that service. It's all unicast into the home, and I think today they have about 500,000 customers already launched in that. So it's quite significant. But the real problem, I think, with ABR is that when you kind of get under the covers, it really is very, very inefficient. You've got these multiple protocols that you have to support. So obviously for the last few years, we've had we've had smooth streaming, we've had Adobe's HDS, and we've had Apple's HLS. And now we've got Dash coming along, and really Dash was supposed to be that great democratizer of content. But basically what we're seeing now is a lot of different flavors. So as part of the Dash IF forum, we're basically defining this Dash 264 standard. There's Dash 3GP. And if you look at people like even Samsung, they've actually invented their own standard, which is HAS, which is their own kind of flavor of Dash. So it is becoming very splintered, even in the Dash world as you're going forward. And again, you have a myriad of devices out there that you require, there's different screen real estates, there's different capabilities on the device, so you need an enormous amount of profiles to manage that. And then you have this wide ecosystem of encryption technology as well. So whether that's Pantos or PlayReady, Dash Common Encryption, or whether you look at one of the commercial vendors that are actually implementing based on the ISO 23001 spec, there's a lot of technologies out there. And then obviously you have an array of different diverse networks, which also cause problems. So if you're delivering content over a very high latency network, longer segments in terms of anywhere from 6 to 10 seconds actually work best. If you're looking at a very low latency network, 2 to 4 second fragments work best. So again, that's all becoming fragmented. And really what we're seeing is this problem is becoming really aggravated when you're adding all these new services. So for example, look back, catch up, rewind type services for time shifting. When you start to do targeted ad insertion, you're now personalizing the content on an ad zone or per DMA basis for delivery into the home. We've got distribution rights to contend with. So, particularly in North America, sports blackout and regional blackouts have to be applied. I know in Europe it's a large problem in terms of device rights. So I may have rights to deliver this particular piece of content to the TV, but not to the iPhone. So how do I manage that? And then if you look at other services, because we're delivering now into the TV, people actually want to do things like they did with the traditional set. So they want to channel surf. So again, how do you manage all that? So really, the problem that we're seeing is this really results in people producing multiple renditions of any piece of content. And it really drives, particularly the cost of infrastructure, very high because you need to scale that infrastructure to deliver. And so really just to summarize, a lot of our customers, again, they want parity with what they're providing on their cable and their IPTV services, but they also want parity in their infrastructure costs. They can't actually scale to support all these formats, all these resolutions, the bit rates, the DRMs that are actually being delivered to these devices. And because they're charging for that content in one way or another, could be through advertising or it could be a subscription service. For them, good enough is not good enough. They really have to guarantee that quality of experience. It can't be that YouTube type, if the video fails, I'm going to click again and hopefully it'll load. And one point here I thought was really interesting. It was actually a study I was reading by Akamai. And people receiving content were actually more willing to take ads than to have actually a poor experience delivering a video. And so that has actually changed, I think, a lot because, the pushback has always been in the past. People didn't want ads associated as part of this video delivery. So there's really a couple of common solutions that people have implemented to try to resolve this problem. And one is really a client-based solution. And so basically, what people have tried to do is consolidate their video delivery into one single format and produce multiple clients that will actually receive and play back that particular protocol. And so really this, has created, particularly with some of our customers, really massive scaling issues. None of them really want to be in the business of building and supporting clients sitting out there on the network. And so I think, I'm not going to go through all this, but I think, really at a high level, if you look at this particular aggregator example, they actually have 47 clients required to support all the services that they're delivering today. And so for a Time Warner or a Comcast or even a Verizon, that's not really a practical solution in order to deliver that. If you look at the content-based solution, it's almost the opposite way. So basically, people are actually taking those VOD assets, they're taking the live linear streams that are coming in, and they're actually creating a lot of different resolutions, a lot of different profiles of that content to deliver up to each device. And the problem there is that really doesn't scale either. If you just look at formats, say for example, if you're delivering to HLS, HDS, smooth streaming, and Dash, that's 4 times you actually have to create that content, you have to store it 4 times, you have to deliver it over the backbone 4 times, and it has to be cached at the edge 4 times. And so really that's a very significant challenge. And that doesn't account for things like, personalization for ads, for supporting different DMAs, for blackouts, that kind of stuff. That's really just 4 formats. And so another really good aggregator example, and again, this is a US aggregator, is that they are today creating 76 formats to actually deliver the content onto these different devices. And that was something I actually did for them in a previous life. And I worked for a transcoder vendor, and that's a very nice model for a transcoder vendor. I know our sales guys were kind of salivating at that. But when it comes to scalability, it's something that's not sustainable. So I think the real problem, if you look at this model, is that effectively you have encoders or transcoders. They're producing 4 formats. Each of these formats have 8 different bit rates. It's delivered into the origin server. It's then pushed through to the cache, and it's then gathered, acquired, and consumed by the clients. And really, if you look at this particular model, for one input stream, you actually have 32 output streams, regardless if the content is consumed or not, because you need to create all those formats, you need to create those bit rates right up front. You have no idea if the client is actually going to ask for them. And then where it becomes really, really difficult is when you start trying to personalize that content. And this is actually an example of a US Tier 1 operator. And so when they were rolling out their service, they wanted parity with their existing QAM services. And so basically, they wanted 1,000 input channels, so it's national and regional channels that were actually being ingested. They wanted 8 different bit rates per channel. They wanted 3 protocols, and they needed to service 200 DMAs or 200 ad zones as part of their network. And so the total input streams required to do that would have been 4.8 million. Total output streams would have been 4.8 million to actually be able to cover all those different formats and DMAs. 60% of the content was HLS, but again, for those niche formats, they're creating that content whether they need it or not. So one thing they came to us and asked us to look at was really the case for repackaging. So if you look at their typical network model today, they have significantly reduced the number of encoders they have. Those encoders are producing one format, so it's HLS only. HLS is obviously being stored in the origin. It's being pulled to the caching infrastructure, and we have our product sitting in there that actually does the repackaging. And so effectively, at the back end, we've reduced those 32 streams to 8 streams being delivered through the network. And in terms of best practices, certainly working with this company, what we found out is that it's really best to try and consolidate all the video libraries and the feeds into a single mezzanine format. If you think about it, really the elementary streams are identical. So the video and audio elementary streams are identical no matter what device they're delivered to. And really all we're doing is rewrapping that content in a different container. So there's really a significant savings on encoders and transcoders, their origins, all their caching servers within the network. Typically, people will actually select the most popular protocol as their mezzanine, so that can actually be passed through. So if you're delivering 60 or 70% HLS content, choose that as the mezzanine, pass it directly through to the device, and then simply repackage for those other niche formats that there's really not a great demand for. The other thing that goes along with that is the ability to use manifest manipulation wherever possible. And so when you're using manifest manipulation, it's really simply repackaging the manifest. So again, you can tailor bit rates, you can tailor profiles for each network, for each device, without actually having to repackage the content itself. So that leads to even greater efficiencies delivering it through the network. Again, we also like to use the generic apps that are embedded in the player itself. So if you're using those silicone apps, they perform much better. And really, in terms of most of our users, they limit apps to something that is used for simply content discovery and branding. So something that they can actually put in front of the user that lets you find, select, and deliver content rather than trying to build out custom players. And then really, most of our customers as well create programming more in just-in-time type methodologies. So they never store multiple versions of the content on the network. Even for things like catch-up and rewind, those manifests, all that programming is actually generated as a bespoke piece of content in response to a request coming from the player. So again, it becomes very, very efficient in terms of delivering content. And for protocols like HLS, this works extremely well. This is a case study that we actually did with, it's a large US MSO, a tier 1. And so basically they have actually built out their own CDN and all that infrastructure based on open source caching. And so when we went in to talk to them about trying to get greater efficiencies, they said, okay, basically, you know, our caching is free. We've built our own resource request router and content request router. That's free. We own the network. So basically, those distribution costs are free. You know, and if you guys can actually come in and do better than free, then yeah, we're willing to listen to you. So the only thing we could really compete against was the cost of hardware. And so if you look on the left-hand side, it gives you a little bit of a description of their network. So they have 300 live channels. They have $50,000 of VOD content they're delivering. They have 11 edge sites, and they're actually delivering about 14,000 concurrent sessions today from each one of those edge sites. And again, in this particular example, they had one ad zone. And so the first bar on the left-hand side really shows their deployment costs. And so at the bottom in the pink, there was the packaging costs. The yellow was the CDN, or sorry, the origin costs. Blue was the mid-tier caching costs. and then the orange was actually their edge caching costs. And for hardware to deliver that, they were paying about $3.5 million. So when we come in, we were able to say, okay, let's go with HLS as your mezzanine format. We're going to repackage that on the fly if required for those devices. We were able to reduce their packaging costs, their origin costs, their mid-tier caching costs, and their edge costs by 66%, and so drive the cost of that down. Even when you look in terms of the licensing costs on our software, because we do sell it, we're not a charity, so we don't give it away, but the blue and the green actually represent our licensing costs and our management costs. We were still able to take that $3.5 million and get them to a price point somewhere below $2 million. So I think it worked out about $1.9 million to distribute this on their network. And again, that was competing basically with free. They like this, so they come back and said, okay, can we now do targeted ad insertion? So to be able to add targeted ad insertion to that, we were able to price it out to about $2.8 million. So even with targeted ad insertion and layering some of these advanced services on top, we were still able to get the price point down to be much less than just their standard generic deployment. And again, this is the worst, absolute worst case for repackaging, because everything apart from the hardware and the network was considered to be free. You also do now start running into cost advantages at scale. So what we're looking at now is let's add another ad zone to that. So now the content is actually being delivered and customized and tailored for 2 ad zones. And so you can see with their existing model, the price was actually pushed up to over $5 million. With repackaging, that price doesn't change because the ad insertion is done bespokely as part of that reprocessing package and actually inserted in the stream as it's being requested by the user. So there's no upfront costs to actually doing ad insertion, blackout management, any of that stuff. So it does scale particularly well in those particular things. One of the other issues, and if you've ever used something like smooth streaming, that's based on the BMFF protocol, is that today it actually provides quite a poor experience, or poor quality of experience for the user. And so, if you're looking at ads or you're looking at content switching within protocols like smooth streaming or HDS, there's a lot of client buffering issues. There's decoder reinitializations. You get a lot of what I would term as player green screens in terms of delivering that content. So it's not that seamless broadcast experience that most people are used to or most people want. And there's a number of issues for this. And so really the biggest challenge is managing discontinuity within a lot of these formats. So if I'm streaming a live channel using smooth streaming, and I'm actually trying to insert an ad in there, there's no support within those players for spatial or temporal discontinuities within the content. So repackaging actually helps in that, because what you can actually do is you can rewrite those content fragments as they're being delivered. So I can go in, I can do things like fix the PTS, the DTS, the codec private metadata, and as that content is actually being delivered to the player, it looks like one single contiguous stream that's actually coming from the back end. And so the player has no concept that this happens to be a different piece of content. Discontinuities are managed on the network side, and the player just keeps playing. Some of the other issues that you'll actually run into, particularly with smooth streaming, is that all the request URLs for segments are actually relative to the manifest. So again, it becomes very, very difficult to do any kind of content splicing, ad insertion, or alternate content within the player itself. But since you're repackaging, all the requests for a particular piece of content are actually coming back to the repackager. This actually takes care of the issue because it resolves that problem. It's the repackager that's actually going out, getting the content, rewriting those fragments, and delivering to the client. So to the client, it's always coming back to the same place to actually get its content once it started that stream. A couple of the other problems you'll see, particularly with Smooth and HDS, is that the audio and video reside in separate segments in their own timeline. So, and that tends to be different, because really the audio and video have different sampling rates, etc., and they're really not synced up, and they may span fragment boundaries. So with repackaging, it allows you to actually sync up the audio and video fragments, particularly as you're dealing with ads and alternate content insertion. The other two issues is really, the next URL request for a lot of the MP4 protocols is actually based, or it's actually put into the fragment that you're currently watching. So even with manifest manipulation, it really doesn't help, because with Smooth, you simply get a manifest right at the beginning of the stream, and you never get another one. So again, through repackaging, you can rewrite those MP4 boxes, and again, deliver that seamless experience down to the user. And then finally, particularly with protocols like Smooth or HDS, the decoder is really only initialized at the start of the session. And so we can actually set policies around that to ensure that you get the right bit rate, you get the right resolution, you get the right codec private metadata. So those decoders never have to be initialized again, and you get that seamless playback experience. So in terms of dynamic content repackaging itself, there's really a number of tangible benefits that our customers are actually seeing. And one is really to be able to deliver to any kind of an ABR device. So it's basically fully supported on the generic client implementations. There's no requirement to have a custom client in any of those devices. The advantage is content is repackaged only when requested. So if you have a number of niche devices that are out there, say, for example, a Samsung TV supporting HAS, there's not a large penetration in the market. So why would you create all that content up front? And so to be able to actually take that and to actually create that content only when requested, it's a huge savings on the network. And the backbone traffic is really significantly reduced by doing that. You can also do things like dynamic refragmentation of the content. So for example, you can now condition streams based on the capabilities of the network that you're delivering to. So if your origin format happens to be in 10-second fragments, you're delivering to a very low latency network, you can now refragment that and deliver that in 2-second fragments. So that's one of the other advantages of doing the repackaging. You can do things like a fast start experience. And so the customer I mentioned in the Caribbean, they're delivering content into the set-top box. They really want, as you flip through your channels, that low latency and that TV-like experience. And so with their implementation, we're actually refragmenting that content. We're giving them 1-second fragment, 1-second fragment, 2-second fragment, 4-second fragment as you're flipping through the channels. So it's very, very fast to deliver. And in terms of their service, as you're surfing, they're actually down to a less than 100 millisecond latency as you're doing those channel changes. So it is actually very fast, and it's actually faster than my cable service that I have at home. You can also do things like support network switching. So with iOS 7, it allows you to jump from an LTE network to a Wi-Fi network whenever one comes in range. So the use case there, I might be watching something on LTE, I go into a Starbucks, I connect, and I can actually swap. So to be able to manage that and be able to tailor that content for a particular network at any given time is something that repackaging also allows you to do as well. Bandwidth management and rate shaping, again, it's something that's always been very, very difficult with ABR protocols. But as you're repackaging it, it actually allows you to manage the bandwidth really in real time and do things like optimize the TCP stack in order to support the optimal data rates. So TCP is actually, as we all know, it's kind of bursty. So on the back end, we can actually manage that. And in most of our deployments, if you're looking at a device that has a 10 gig NIC, we can actually achieve a constant sort of 9.2, 9.3 gig output on that device without the burstiness. So we'll manage that rate, and we'll control all that rate shaping to get the greatest throughput that we can from the box itself. And then we can obviously optimize bit rate, based on policy. And so a really good example of that is we have a customer that actually offers a quad play service. And so as part of the quad play service, they have a VoIP component. So as the VoIP component goes off hook, we'll actually reduce the video being delivered into the home by half a megabit to actually give you the best quality VoIP experience that you can. Once that soft phone goes back on hook, we're actually going to bump that bit rate back up again and dedicate more bandwidth towards the video. And so again, there's other ways to do it. You can manage it through diff-serve tags and stuff like that. But it's really something that's enforced by policy by the soft phone within our software. Some of the other interesting things, we spoke a little bit about content personalization, but as you're repackaging content, you can now start generating bespoke programming. So what do I mean by that? So basically, as content is actually being ingested, many of our customers will actually archive that content on the fly. So they have, for the last, sort of 30 days, they have a complete listing of all the programs that's actually being delivered, and that's archived on a server in the back end. And so based on any request that comes into us, we can actually we can pull that content from the channel and we can build a program based on that. So for example, if I happened to miss CSI last night at 9 o'clock, I can simply go into my reverse EPG, select that, and it's going to go and build that program for me and deliver that program for me on the fly. We can also do things like one of the services that we're launching with a large MSO is it's for the NFL, and it basically gives you the ability to see all the touchdowns because I think there's 16 games on any weekend. Obviously, people don't have the ability to watch that, so they're going to put markers in the stream, and we can actually deliver just the highlights or just the touchdowns from those games based on what was archived as part of that delivery. The other interesting thing is, and the studios actually like this, is once you're repackaging, and because you're touching all of these fragments that actually happen to be sitting in the network, you can now start doing some interesting things with security and rights management. So with repackaging, you can now start adding per session DRM and per session encryption. And so really what happens is when I'm encrypting a piece of content, I'll retrieve a key. I'll use that key for the duration of the session or multiple keys of this key rotation. Then those keys are retired. So basically, even if someone were to hack the key or someone were somehow to pass that on to a friend to actually retrieve the content, that key is actually never used again. So it effectively becomes quite useless. And really, we can eliminate the need based on that to encrypt for every single device, every single DRM, and every single player combination. So effectively, it gives you the ability to apply that DRM only when requested. And there's a number of different models that can be supported as well. So there's obviously the clear to encrypt. So if your content is sitting on the network in the clear, it can be encrypted as part of that delivery process. We can do things like decrypt to encrypt. So particularly once you get outside of the US and get into South America or Asia, there's a large requirement to have all your content sitting encrypted within the network. So as part of the workflow, you can ingest a piece of encrypted content, decrypt that, repackage it, re-encrypt that, and send it out to the user. And because it's all done in memory, it's all secure, it never gets written to disk, so the content throughout the workflow is never written out in the clear to any kind of storage device. And then there's obviously pass-through. So if you want to make use of the DRM that's already applied to that piece of content, it can be simply passed through. And you can also do repackaging with pass-through if the content is encrypted at the sample level, because we actually don't touch the video. Those samples can actually be repackaged, and that same DRM can be used and can be passed through. One of the other interesting things that we're talking to a lot of the studios about is this concept of per session watermarking. So that can be done today as a piece of content is being requested. It's given a unique watermark and delivered up to the player. And so by doing that, I know that this particular unique user ID was used to acquire the content. I know the device. I know the player type, I know the date, I know the time, I know the user ID, I know the IP that was actually delivered up to. So if that content were ever to make its way onto YouTube, I can actually just take that, drop it into a portal, and I can get a listing of, who actually received that content, when they received it, and so it's up to the rights holder if they want to take any action against that. One of the interesting things is that a lot of the studios really see this as a requirement for 4K because they're terrified about putting 4K content out there in the network without the watermarking. And the reason being is that, I can pretty much put a video camera in front of my TV. It's like pointing it out the window and capture a really, really good quality rendition of that content and be able to archive that. And so even with security on the interfaces, they still see, the video cameras really being the way to pirate 4K content. And so with those guys, obviously, precision watermarking really makes a lot of sense. The other two things I did mention a little bit were digital ad insertion and content substitutions and blackouts. So because we're now repackaging that content on a per stream basis, what we can do is actually now go in and actually begin to really hyper-target people with ads. So I know, for example, that today, Time Warner really have things like, they've really 8 DMAs that they target. So male, female, and then a number of demographics, so 18 to 25, 25 to 35, et cetera. But where a lot of the US MSOs are going in the future is they really want to be able to do this hyper-targeting. So they know, basically, it was Brian. They know he's between 40 and 50. They know he's been watching a lot of this type of content. And so when they pass that request into the ad decision system, it's supposed to actually return me something that would actually be of interest in terms of watching. And just based on some of the figures that they're producing, they're actually seeing, there's really this sort of 2 to 5 times uplift in CPM for those figures. Now, I don't know if they'll ever get there. Certainly the DMA model is what's prevalent today, and it seems to work, but it's definitely something that they're thinking about. The other thing to bear in mind, too, is because ads are actually stitched into content as part of the repackaging, they're unaffected by ad blockers. So again, the player has no concept that's actually watching an ad in the stream. All the network PSNs, or the placement status notifications, are done from the network. And so basically, it really reduces the ability, or really reduces the revenue leakage for clients not reporting ads that were actually played back. And you can have all your basic models, so it can be live or on demand, post-roll, pre-roll. You can do insert, you can do replace, depending on the type of content. But it works for any protocol, and it's seamless in terms of the experience on the player. Similar with blackouts, again, you can enforce content rights management. Probably per DMA it would be the logical place to do that. And so either based on location, based on device type, based on network type, you can actually substitute alternate content instead of the programming if you don't have rights to deliver that. And invariably, sort of the question that always comes up is scalability. So you're taking this content, and on a per session basis, you're actually decoding it, you're extracting the elementary streams from the container, you're inserting ads, you're repackaging it, you're re-encoding it, and you're sending it out. Surely that can't scale, and that's really the first question that you typically get from an MSO. But if you look at our environment, or delivery environment, typically we recommend a single Intel E5 processor, which is pretty much equivalent to a standard i7 consumer grade processor. If you're looking at a typical box, it's got 48 gigs of memory, 1 terabyte of disk space, and typically a 10 gig NIC or 2 bonded 10 gig NICs for content delivery. And so if you look at the performance figures, and worst case would be to do HLS to smooth. So you've got to ingest HLS, you've got to rebuild all that timing information that's missing. We're looking at a round trip of about 60 milliseconds through the box to actually repackage that content. And so don't forget, we're simply recontainerizing it. We're not transcoding the underlying base media file format. On this type of box, you're looking at up to about 7,000 users per session, or 7,000 individual sessions per box. And then in terms of the throughput, we can sustain about a 9 gig, somewhere between 9.2 gigs on that NIC. So it really does become very efficient. Now, in reality, the session count tends to be a little bit lower, because as you get up into the higher bit rates, obviously the constraint really becomes the NIC, and that really limits the amount of content that can be delivered from the box. And really, in the case of the overview I showed you for the large MSO, basically they took us and they actually deployed our software on the box with the caching software. So they're both co-resident on the same box. The caching software is very I/O bound. We're very much CPU bound, because we're doing all the repackaging. And so the result is they're not getting 100% utilization out of those boxes, both in terms of I/O and CPU for the delivery. So for them, it was sort of a win-win situation, because now they can actually use these boxes to do the repackaging and get those efficiencies in the network, all with the same hardware that they'd have to buy anyway. And so I guess that's it.